You can save money and improve the environment by making informed choices when replacing or upgrading your heating, air conditioning, or hot water systems. We are going to look at relative energy costs and discuss different types of systems. You will learn about heat pumps and why we're all so excited about the performance of current high-efficiency models. Home heating contributes about 9 metric tons per year of greenhouse gases per household. We can bring that to essentially zero with the right choices. Join us in a simple 4-step program. 1. Leverage a home energy audit and reduce your consumption. 2. Purchase clean energy or install rooftop solar. 3. Make a plan for your systems and install a high-efficiency heat pump when it's right for you. And 4. Save money. Home heating, cooling, and hot water systems typically last 20 or 30 years. And our goal is to eliminate greenhouse gas emissions within 20 years. So it's really important to have a plan and make the right choice. Take the time now to study options and develop your plan. Don't wait until the last minute and your system fails and you're forced to make a quick decision. You have an opportunity to make the world cleaner, safer, and sustainable, and save money in the long term. How can we heat our house? Well, one option is to burn something like oil, gas, wood chips to make heat, but that's always going to produce carbon dioxide and other pollutants. You could also use clean electricity to make heat by resistive heating, like in a toaster. That's really the most expensive to operate, and now it's obsolete, although some of these old electric baseboards are still in use. The amount of carbon emissions from a system like this would depend on how the electricity is produced. A better option is to move heat from where it is, whether it be in the air or in the ground, to where we want it inside our homes with a heat pump. We need electricity to do this. It's kinder and gentler to the planet. It may be cheaper depending on your current heating system. And the electricity can come from a renewable source, as we mentioned earlier. And the system of a heat pump will do dual duty and act as a traditional air conditioner in the summertime. Another option is to use sunshine directly. A passive solar house is really the best option. It's great for new homes, but it's not easily retrofit into existing homes. So we're not going to focus on that today. We should choose a system that adds no carbon dioxide and minimizes other pollutants. Is it really possible to choose a system that's clean and saves money? Well, let's find out. First things first, let's take step 1, and that is to minimize the amount of energy and understand the energy use in your household. Get a free energy audit. You can visit the NYSERDA webpage to find details on how to do this. You'll probably find that you need to insulate better, minimize leaks, perhaps install a smart thermostat. You need to maintain your equipment with tune-ups and always change your filters regularly. You should pay attention to what spaces really need to be heated or cooled, and don't condition spaces that you're not using. Don't leave doors and windows open with the heating or the air conditioning running. I do not recommend you use an open fireplace. It pulls more heat out of the house than it actually generates. But if you do use one, close the damper securely when you're finished. All of this can impact the size of the equipment needed and future heat pump requirements. We are going to step back and discuss the efficiency of fossil fuel-fired heating systems. All combustion sources produce CO2 and other toxic gases. These are vented outdoors via a chimney or pipe and always contain heat. Because of that heat loss, the efficiency of these units is always less than 100%. By the way, another way to quantify efficiency is coefficient of performance, or COP. That is simply heat output divided by heat input and is 0.8 or 0.9 when rounded for these cases. These heating systems typically distribute heat through the house either through hot water and baseboards or hot air and ductwork. Over the years, as we have continually extracted oil and gas from the earth, the reserves are getting harder and harder to reach, and often in more environmentally sensitive areas like our oceans. In addition, A technology called fracking is used to extract more from existing wells. Fracking involves pumping water and chemicals under extremely high pressure into the earth until cracks and fractures occur. These allow more of the trapped fossil fuels to escape, but cause other consequences such as groundwater pollution and methane leaks, which is a worse greenhouse gas than CO2, by the way. So, bottom line, extracting oil and gas results in significant environmental consequences in addition to CO2 emissions. What about biodiesel? Well, you can't burn corn stalks or soybeans in your home or your car, so a lot of processing is needed, and it consumes fossil fuels. The ideal biodiesel would grow in a 1-year life cycle, yield far more energy than required to make it, and require no fossil fuels to grow, harvest, and process. This is not yet the case. However, properly produced biodiesel blend has been shown to reduce carbon emissions in total, and New York State provides a tax benefit those who use it. We recommend using 20% biodiesel, known as B20, as it is the least net expense to you and has a net carbon dioxide benefit. And it avoids some of those other negative environmental consequences we talked about with fossil fuels. Note, it is not recommended for outdoor storage tanks as it may partially solidify in extreme cold. While still burning fuel oil, it is imperative to keep your burner tuned properly. Some might question if the company that sells you oil is motivated to minimize your consumption. I recommend you get a written report from a company that utilizes the latest technology for measurements, such as a digital meter that measures oxygen, unburned fuel, and stack temperature. After you get the report, I suggest you discuss it with neighbors and experts. Oil burners have improved over the years, but will yield efficiency in the high 80s at best. As you can see from the table, you want to minimize stack temperature and excess air. Minimum stack temperature for residential systems is around 350 degrees. I would be concerned if it is above 500 degrees. Keep in mind that all that heat is just thrown out through your chimney. The person that tunes your boiler adjusts the oil burner flow, which is the tip size and excess air, and has a big impact on your household emissions. Now let me introduce you to heat pumps. As you know, typical air conditioning extracts heat from inside and moves it outside. An air source heat pump operates just like your air conditioner in the summer, but in the winter it operates in reverse and extracts heat from the outdoor air and moves it inside. In all cases, heat pumps operate at efficiencies greater than 100%. These units are very efficient and operate between 160 and 500% efficiency. That may surprise you, but keep in mind we are talking about moving heat, not creating it. Let me give you an example. Say your house is 60 degrees inside and the weather outside suddenly warms up to 75 degrees. You open the windows and the house warms up to 70 degrees. The efficiency of that activity was perfect and obviously much greater than 100% since you used no electrical energy and used the heat in the outdoor air to heat your house. The heat pump does essentially the same thing by extracting and consolidating heat from outdoor air and moving it inside, but it can pull heat from fairly cold air. One more thing about the efficiency of air source heat pumps. It goes down as the temperature goes down. That's why I show the range of 160 to 500% efficiency. Ground source heat pumps operate on the same principle. They take advantage of the constant temperature in the earth to gain efficiency. They require that a well or trenches be excavated and operate around 430 to 450% efficiency. They have a dual benefit of saving energy in both heating and cooling situations. As we migrate to electricity to heat our homes, it's important that the source of that electricity be clean and renewable. Wind, solar, and hydropower provide clean, renewable energy. You are free to choose any company you want to provide your electricity. These companies are called energy service companies, ESCOs. Choose one that provides 100% sustainable renewable energy, Or you may select to choose community solar, which is available through Sustainable Westchester, and in that case you can save 10% off your electric bill. In all cases, your utility will still provide the service and maintain distribution. The Con Ed or NYSEG websites will provide direction. Have you considered installing rooftop solar? If you have good sun on your roof and a south to southwest exposure, if you have a roof in good shape with say 25 years remaining on it, or if you're installing a new roof. And if you pay a high utility rate, the higher the rate, the better the savings. Today's systems look cleaner. They have a 25-year lifespan. There are great incentives now. I've looked at net present value of a solar system in Con Ed territory, where we have some of the highest utility rates in the nation, and it will save 35 to 50% of energy costs depending on your financing rate. Now let's talk about a subject near and dear to all of us, operational cost. This is what you pay month after month and year after year to heat your home. To make it simple, I have calculated all costs relative to the cost of oil heat. So the cost of oil heat relative to the cost of oil heat is 100%. If, for example, you heat with propane, your cost will be about 40% more. If you heated with old school baseboard electric, as we discussed earlier, it would be almost triple. High efficiency gas is currently good from a cost viewpoint, but results in CO2 and methane emissions, both greenhouse gases. It is produced with fracking, which has many negative environmental consequences. Today's gas prices are the lowest they've been in the past 20 years. In 2005, for example, gas was about 10 times more expensive than it is today. It is uncertain what it will cost in the future. For all electric systems, I figured that the homeowner purchases from a clean ESCO, as we previously discussed. You notice that for air source heat pumps, I show a range. This is because the efficiency of air source heat pumps varies with outdoor temperature. Thus, depending on the average temperature of a given winter, the cost can vary. I'll talk about this more on upcoming charts. The efficiency of other fuels and geothermal for this calculation are constants. I've also shown relative costs for a geothermal system. It has the added benefit of cutting your cooling costs, probably about 50%. Where I included solar, to be conservative, I included the cost of the system in the operating costs. The actual operating cost of a rooftop solar system is close to zero. Costs of fossil fuels vary with changes in the economy. For that reason, there can be no guarantee as to what system will be the lowest cost in the future. These costs are based on data from first quarter 2020. When making your final decision, you may calculate more precisely using the tool from Efficiency Main. You will have to make a judgment as to what you think will happen with future energy costs. Note that so far, we have only discussed operating costs. These are the costs you pay month after month, year after year. Installation costs vary widely depending on your existing conditions, and we'll discuss this further in an upcoming slide. Each business case will be different. So, what's the best choice for clean, low-cost heat? A high-efficiency air source heat pump gives good cost performance and no emissions, and they're getting better every year. Geothermal is even more efficient on the average. Adding rooftop solar, if your location is appropriate, reduces that cost even more. Geothermal provides excellent operational costs and is not subject to outdoor temperature variations since it operates below the surface of the earth where the temperature is relatively constant. Combining geothermal and rooftop solar will result in the lowest operating cost and has essentially zero emissions. The time to plan and understand all of this is now. Now let's examine the relative cost of installation. You can see that a heat pump will cost somewhat more than replacement of a furnace or central air conditioning. It may well save you operating costs, however, and if powered by clean energy, will produce no carbon emissions. I would never buy another plain air conditioner again. I've shown some ballpark costs for geothermal. There are great incentives for this type of system, and it may be right for you. It does take up more space in your utility room, but saves money when it's very cold or very hot outside. Rooftop solar is often a wise and cost-effective investment, particularly if Con Ed is your supplier. Now, let's turn our attention back to heat pumps. What do they look like? Well, they just look like air conditioning systems. If you have central air or a ducted system, the outside and the inside will pretty much look the way it does today. If you have a mini split or ductless system, they will look the same as they do today. However, again, they can operate either pumping the heat into the room or pumping the heat out of the room. Let's talk about what equipment you'll need to migrate to a cold climate heat pump. This depends on the starting point. What system do you have currently installed? If you have gas or oil-fired hot air, you simply need to install the heat pump, which again functions as your air conditioner. If you have gas or oil baseboard hot water or electric baseboard, that means you don't have ductwork. You'll need to either install a fully ducted system or a number of wall-mounted air handlers to distribute the air within your house, and then the heat pump. This will be a more expensive transition. But if you have central air conditioning, regardless of what type of heat you have, you should install a heat pump that will provide you heating and cooling through that single system. You might be thinking, perhaps you don't want to replace an entire system. Maybe you have a fairly new system, but you'd like to do something in the right direction. Is there some sort of hybrid? Well, the answer is yes. A heat pump powered by clean energy can work with and complement your existing system. It'll reduce your carbon emissions and potentially save you money. Now we're going to talk about efficiency and what you would specify if you're purchasing a heat pump. In all cases, a heat pump also functions as an air conditioner, and you will need to specify a cold climate heat pump if you're going to use it for heating. The efficiency of these units drops as the outdoor temperature goes down. And to compensate for this and sort of give you an average number, they are now rated by Heating Seasonal Performance Factors, HSPF, and that's in BTUs per watt hour. You would simply multiply that number by 0.29 to get an average coefficient of performance. It's sort of like the difference between degrees Fahrenheit and degrees centigrade. It's just a conversion factor. In all cases, higher means more efficient. However, more efficient units cost more. The range for heating HSPF goes from about 8.5 to 15, and I would recommend that you purchase a unit greater than 10. For cooling, the seasonal energy efficiency rating varies from 15 to 42, and I would recommend at least 20 for that number. The U.S. government actually has a website that has the ratings of every unit that's in production, and I included that link here for your reference. Keep in mind, after you choose your heating system, you will still need a plan for hot water. Heating systems and hot water systems often go hand in hand. Sometimes they're integrated, sometimes they're completely separate. So you'll need to make a choice as to how to provide hot water. For many people, the heat pump hot water heater will be the best option. And by the way, it also acts to dehumidify your basement. It'll operate at 2 to 3 times the efficiency of a regular resistance hot water heater. However, if you use very little water, that old style resistance hot water heater may be fine for you. You could also go with point of source electric tankless water heaters, or you could choose a solar thermal hot water system. However, these systems have been falling out of favor in recent years. The economics of your choice depends on site-specific conditions and the amount of hot water used. And remember, check incentives. I have examined the cost for hot water for a typical family of 4 who are pretty energy conscious. You can see that it may cost from about $500 to $2,500 a year depending on your system and your utility. There are 2 great clean solutions, rooftop solar and a heat pump water heater if you're in Con Ed territory, or a heat pump water heater in areas serviced by NYSEG. The most expensive to operate are resistance, electric, and propane systems. Note that current oil prices have been dramatically lower due to the COVID situation and may not extend into the future. This is a photo of an actual house in Yorktown Heights, New York. It was built about 4 years ago. It's very well insulated, has rooftop solar, heat pumps for heating and air conditioning, a heat pump hot water heater, and energy efficient appliances. Look for the Energy Star label. Bottom line, the house is very comfortable. It costs about 15% more than standard construction initially, but it makes more energy than it uses and emits 0 greenhouse gases for the life of the home. That's about 225 metric tons saved over 25 years. Wow. Now it's time to talk about step 3, your plan. What should it look like? It's simply all the activities with their associated time frames. Each home will have a unique plan. I would recommend getting your home energy audit done right away. Have your friends and neighbors do the same. Then you can all discuss it as a group and learn from each other. Switching to a clean ESCO may or may not save you money, but it will reduce your carbon emissions. I added a line to remind you to consider your emergency generator. If you switch to all-electric heat, you will need a larger generator. I recommend you revisit your plan annually. Kick it around with your friends and neighbors. Now it's time to take this journey together. Let's make good choices for a sustainable future. Let's each and every one of us eliminate that 9 metric tons per year of household emissions. Let's take advantage of rebates and incentives. While you do this, get good advice, qualified contractors, and always get multiple bids. Take our 4-step program. 1. Reduce your energy use. Leverage a good home energy audit. 2. Purchase clean energy from a clean ESCO or install rooftop solar. 3. Make a plan and install a high-efficiency heat pump when it's right for you. And 4. Something we can all enjoy, save money. I look forward to taking the journey with you.